Now it's time for Privacy Talks. Privacy Talks features interviews between Privacy News Online's Caleb Chen and influencers, activists, and experts from pro-privacy organizations around the world. Let's go to Caleb, who recently caught up with Josh Ose from Let's Encrypt to ask him some questions about HTTPS, encryption on the internet, and ways to bolster that security.
Hello and welcome to Privacy Talks. This is Caleb Chen from Privacy News Online, and today I'm speaking with Josh Ose from Let's Encrypt, a nonprofit certificate authority that issued their billionth certificate a few months ago. Josh, thank you so much for taking the time to talk with me. We're very excited to have you.
Thank you. Happy to be here.
So to start off, could you tell us what Let's Encrypt does and what led you to co-found it?
Sure. So as you mentioned before, Let's Encrypt is a nonprofit organization, and we exist in order to help protect the connection between a website and their visitors so that information going between websites and their visitors can't be spied on and it can't be modified. The reason that I started Let's Encrypt is that I used to work at Mozilla. I was there for 10 or 12 years or something like that, working on the Firefox web browser. And one of the things I worked on was the networking stack. So that's all the networking code in Firefox that helps make connections with websites. Sort of an endlessly frustrating thing for us is that there was nothing that we could do on the Firefox side to make sure that the connection between Firefox and a web browser was secure. Firefox and a website was secure. The website would have to enable something called HTTPS in order for the connection to be secure. And getting every website in the world to enable HTTPS would be difficult and take a long time, especially with the tools available at the time. So I thought long and hard about what would the world need in order to get many, many millions of websites to enable HTTPS for secure connections. And I talked to a lot of other really smart people who helped me come up with a plan. And we ended up launching Let's Encrypt. And the goal here is to make it easy and free for people to get the certificates that they need to enable HTTPS. So the biggest barrier, the reason websites weren't enabling it, was like getting the digital certificates that they needed, paying for them, and figuring out how to do it was just too complicated, or people didn't have the money, something like that. So that was the real barrier. So we wanted to start a new certificate authority that was free and very easy to use, and that's Let's Encrypt.
Very glad that Let's Encrypt exists now. Could you give a quick explainer of what HTTPS is and what role Let's Encrypt plays in enabling HTTPS?
Sure. So let's start with HTTP. HTTP is essentially a way for websites to request things. So they can request that a resource be sent to them, like a website, or they can request that a file be put somewhere or something like that. So HTTP is just a system of requests, essentially. But on its own, those requests are not secure. So when you request a web page and it gets sent back, all of that is in the open. That traffic can be seen by anyone along the network path. It can be modified by anyone along the network path. So we want to secure that traffic. And the way we do it is by wrapping it in sort of a cryptographic tunnel called TLS, Transport Layer Security. It used to be called SSL. So we build this secure tunnel where anything going through the tunnel is encrypted. It can't be seen, it can't be modified. And then we speak HTTP through that secure tunnel. And when you're doing that, that's called HTTPS, and the S stands for secure. So HTTPS is just HTTP through a secure TLS tunnel. In order to do this, you need a certificate, and the certificate tells you what cryptographic keys to use for a particular website. So you want to use a key where you can encrypt traffic and only the website can decrypt it, not anybody else. But in order for this system to work, you need to know which key to use for which website. So Let's Encrypt issues digital certificates that associate a cryptographic key with a domain name, so that if you want to connect to that domain name, you can check to see that we have certified that a particular key can be used with a particular website safely. Historically, those certificates were very difficult to get. Even very technical, smart people had a hard time. It would take hours. They're also expensive. They could cost anywhere from, $25 to hundreds of dollars, maybe thousands of dollars. So a lot of organizations just chose not to do it. And that led us to a situation where most of the web was just unencrypted. So I think that people running websites want to do things the right way. They want to do things the secure way. But in order for them to do that, they have to be able to do it easily enough so a normal person can get this job done quickly and cost effectively. And it just didn't used to be the case. It just wasn't possible in the past. So we created Let's Encrypt. We run a service where people can get these certificates in a matter of seconds using automated tools, and it doesn't cost anything. And people have responded really well to this. So since we started, we have issued well over 1 billion certificates. We currently serve, I think, almost 250 million websites. That's a pretty large percentage of all the websites on the web. The statistic I really love, though, is that when we started, about 39% of all page loads on the web are encrypted. Now that number in the United States is up over 90%, and worldwide it's up over 80%. So we're making a lot of progress towards a web that's 100% encrypted, and that's pretty exciting.
That is very exciting. Could you give us a quick explanation of Let's Encrypt's certificate transparency log?
Sure. Certificate transparency is a tool that was created to help make the certificate ecosystem better. I believe it was invented inside of Google, but a lot of people have taken it up and contributed to the system. Essentially what it does is the world trusts certificate authorities to issue the certificates for HTTPS. But we want to give you some reason to trust us, right? We don't want to say blindly trust us. So what we do is every time we issue a certificate, we very quickly put it into a public log called a certificate transparency log. And the way this log is set up, it uses some fancy math to make it what's called append only, meaning we can always add certificates to the log, but we can never take them out, and we can never modify things that were added in the past. Otherwise, people would know that we had done that. People would know that the log had been tampered with. So we can only ever add certificates to it. And once these logs are public, or once the certificate is public in the log, people can see what we've been doing. They can see if we issue certificates that we shouldn't issue. They can see if maybe they find a certificate that's in the wild that's not in a log. That might be a problem too, because that means we issued a certificate that we didn't know about, because if we knew about it, we would have added to the log, right? So the fact that we have this append-only log of all the certificates that we issue, and actually for every certificate authority now, really helps the world understand what certificate authorities are doing, like Let's Encrypt and all the other ones. And that transparency gives people more reason to trust us. So it's been a really useful tool for watching what CAs are doing, how they're behaving, and building trust with the public.
Could you tell us about the new MultiPerspective Validation process that Let's Encrypt launched this year?
Yeah. So we're always thinking about ways to move the certificate authority ecosystem forward. And security is a big topic for us. So how are we going to move security of certificate authorities forward? Like I said, the public trusts us to do things, and if they're going to trust us, then we need to be secure. So some security threats are very, very deep. So in this case, this multi-perspective validation that we do now is in response to problems with a fundamental internet protocol called BGP. And BGP stands for Border Gateway Protocol, and it essentially is the protocol that helps decide how traffic gets routed around the internet. So if you are in Minneapolis, Minnesota, and you want to send some data to Paris, is that traffic going to go through Chicago? Is it going to go through Toronto, New York? How exactly is that traffic going to get to Paris? BGP is essentially the protocol that decides on that routing. The problem with BGP is that it's not secure, almost at all. We are starting to secure it, but a lot of the internet has not taken up secure BGP yet. if an attacker can manipulate BGP, they can route traffic kind of wherever they want. So if you can route traffic wherever you want, you can cause a lot of problems. And in particular, you can cause a lot of problems with how certificates are issued. You can potentially cause certificates to get issued to you that should not have been. So for example, you could pretend to be a major website like Google or Facebook or something like that. And that would be a big problem. So we have to think about, what are we going to do given the fact that we can't necessarily trust traffic to be routed in the right way on the internet because BGP is not secure? Now, we're not going to be able to fix BGP anytime soon. Fixing BGP is going to require many, many people and organizations to get involved. It's going to take at least a decade, if not 2 decades. So we can't depend on BGP getting fixed, but what we can do is we can make it much harder for people to pull off successful BGP attacks. So one of the ways that we do this is, instead of sending our validation traffic out from one perspective on the internet, we send it from 4 perspectives. And what this means is, you've got traffic originating at 4 different addresses going to the same place. And if you want to attack us, you now have to attack at least 3 of those 4 perspectives successfully at the same time. Before we had multi-perspective validation, you could pull off 1 BGP attack and trick us into doing something we shouldn't do. Now you can still attack us, but you have to pull off 3 successful attacks in 3 different parts of the internet all at the same time, and that is much more difficult. So we haven't solved the problem, but we've significantly raised the bar for how difficult it is to successfully pull off these attacks. So that's what multi-perspective validation is. I think it's one of the best things that we can do short of actually fixing BGP. And we hope that we can demonstrate that this works really well and is something that all CAs can do and help move the industry forward.
Very innovative. Lastly, what is something that Let's Encrypt is looking forward to?
Well, like I said, our goal here is to get to 100% encrypted internet. And I think we've made a ton of progress. The last 5 or 10% in the US or 15 or 20% worldwide is going to be a little more difficult, right? The people who have held out this long have more deep reasons for having held out. So we're going to keep pushing. And I really hope that we're going to get to 100% in the next 3, 4, 5 years. I would love to see encryption required so that your browser really won't let you visit a website unless it is encrypted. I think that's ultimately where we need to be. That's the only way to really protect people. So I am really looking forward to that. To throw out something here that's not directly related to Let's Encrypt and HTTPS, another thing that I'm very excited about is the internet's sort of renewed push for memory safety. So there are certain languages out there like C and C++ that people use to write code. And that code is not memory safe, meaning there are bad things that can happen to the way that those programs manage memory. And those problems are very hard to fix. Even the best C and C++ programmers make mistakes, and those mistakes turn into they turn into security vulnerabilities. So we have a lot of experience that says writing code in C and C++ and other languages that are not memory safe is dangerous. Doesn't matter how good of a programmer you are, or how many tests you run, or how many fuzzers you run. That stuff is dangerous. And I think as an industry, we need to get away from it. We've known how bad it was for a while, but as the years have gone by, we've gotten better and more realistic options for replacing those languages. So I'm very excited about the fact that people are starting to understand how dangerous C and C++ and memory unsafe languages are, and that we have great options for replacing that code these days. So I'm very excited to see the internet industry and the software industry in general start more quickly moving away from unsafe languages so that we can all have safer software.
That's it for the questions today. Thanks again, Josh, for joining us. To our viewers, if you'd like to learn more about Let's Encrypt, do check out the link below. Thank you for watching this Privacy News Online special feature. Make sure you subscribe to see more interviews like this, as well as the top privacy news stories from around the world. Till next time.
Privacy News Online is brought to you by Private Internet Access, the award-winning no-log VPN service who reminds you to always use protection.